Welcome to the another session in Frontiers in CFD. Today we will see the thermal management of lithium-ion battery pack with aluminum block, and these blocks have some kind of channels through which the fluid is flowing. So the today's objective is to generate the geometry of lithium-ion battery pack with aluminum blocks, and in that block the cells are being inserted, and we have some fluid which is flowing through the channels. So the channel is actually in coordination with the rectangular blocks, and through that there are some channels and through which fluid is flowing. We have to generate the mesh. We'll check the different sizes of mesh, whichever is suitable depending on the capabilities of our computer, and finally we'll run the setup and visualize the simulation. So this is in more detail view of the object. So this is the top view on the left hand side which you are observing. On the right hand side view, this is actually the side view of an object. Side view in the sense these are the four channels which are there. So how they are, at how much distance they are been available, so this is been specified here, and accordingly the geometry has been prepared. So the detailed dimensions with reference to the earlier image, so here are the more details of the object along with the side view of an object. This is shows you the top view of an object, and accordingly the geometry has been prepared. So welcome you all. Today we will see the CFD simulation for thermal management of lithium-ion battery pack. This battery pack has rectangular blocks uh, in which the cells are being placed. The cells are being provided with the casing, and there are some channels through which the fluid is flowing. So with this arrangement we are going to see how the flow uh, helps to cool the lithium-ion batteries. So let's start with the workbench window. So these are the general dimensions that we are going to follow. So based upon that we will prepare the geometry, and accordingly we will proceed further for the simulation. So geometry may take some time as it is slightly a lengthier process. So we'll go through the complete process first, and then we'll go to the simulation part. So first of all, start with the fluid flow fluent option. Go to the geometry, click on new design modular geometry. So first of all, set the units to mm. So once you open the geometry, set the units to mm. Click on any one of the plane, let us say x, y. You can see x is red, y is green, and z is blue. So first of all, what I will do, I will create a primitive, that is a box. Instead of add metal, I will make it add to frozen. So as per the dimensions that we are having, so 130 by 77, so this is the end dimension we are having. So I will put it 130. This is z component will be 77, and height will be equal to 65. So this is the block arrangement which we are having. So once the block has been generated, now it's time to proceed for preparation of cells and along with the casing. So cell diameter is 18. So create, go to the primitive, that is cylinder. Instead of add metal, I will make it slice metal. So y component I will take it 65, z component will be equal to 0. Radius I will take it 9, and the location will be my, so the first one is 14.5 and 25. 14.5 and 14.5. So take it 14.5. Z component also equal to 14.5, and this will be the first position. Make it generate. So create one more time primitive, that is cylinder. Instead of add metal, make it slice metal. Y component will be 65, Z component will be equal to 0. So X component now again 34.7 and 14.5. So make it 34.7, and this is Z component will be equal to 14.5. So this will be the second position. Let's make it generate. So create primitive, that is cylinder. Instead of add metal, make it slice metal. The third position is 54.9 and 14.5. So this is 54.9, and this is your 14.5. Y component will be equal to 65. Z component will be equal to 0. Let's make it generate. So one more time, create primitive, that is cylinder. instead of add metal make it slice metal. X component will be equal to, sorry, X component will be equal to 75.1. This is 75.1. Z component will be equal to 14.5. Y component will be equal to 65. This will be equal to 0. So let's make it generate. So create primitive, that is cylinder. Instead of add metal make it slice metal. X component will be equal to now 95.3. So this is 95.3. Z component will be 14.5 as it is. Y component will be 65. Z component will be equal to 0. So let's make it generate. So create primitive cylinder. Instead of add metal make it slice metal. Y component will be 65. Z component will be equal to 0. And your location will be equal to 115.5. 115.5 and Z component will be equal to 14.5. So this is the first location we are having. So we have generated 6 cells. So accordingly we'll do it for the second row. So instead of add metal make it slice metal. X component will be equal to 14.5. Here Z component will be now equal to 38.5. So this is 38.5. This is equal to 65. Let's make this is equal to 0 and generate. So this is the second position. Create primitive cylinder. Instead of add metal make it slice metal. So now X component will be 34.7. So put it 34.7. Z component is 38.5. So make it 38.5. Y component will be equal to 65. Z component will be equal to 0. And let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal make it slice metal. X component will be equal to 54.9. So put it 54.9. This is 38.5. Y component will be 65. This is equal to 0. So let's make it the generate. So create, go to the primitive cylinder. Instead of add metal make it slice metal. Z component is 38.5. This Y component is 65. This will be equal to 0. And your X component now will be equal to 75.1. So put 75.1 here. You will be having the fourth one. Let's make it generate. So create say primitive. Instead of add metal make it slice metal. Z component is 38.5. This Y component is 65. This will be equal to 0. Now let's take the position of X. So now 95.3. So put X component as 95.3 here and let's make it generate. So create one more time primitive cylinder. Instead of add metal make it slice metal. Z component is 38.5. Y component is 65. This is equal to 0. Now X component will be equal to 115.5. So 115.5. Let's make it generate. So second row is also been done. So let's proceed with the third one. Cylinder. Instead of add metal I will make it slice metal. X component is equal to 14.5. So this is 14.5. This is Y component is 65. This is equal to 0. And the 62.5 is your the Z component. 62.5. Let's make it generate. So third one is been done. So one more time, create primitive cylinder. Instead of add metal make it slice metal. X component now will be equal to 34.7. So put it 34.7. Z component is equal to 62.5. So put it 62.5. Y component is 65. This Z component is equal to 0. Let's make it generate. So create primitive cylinder. Instead of add metal make it slice metal. Z component is 62.5. This is equal to 65. This is equal to 0. And let's take the X component now. It is equal to 54.9. So make it 54.9. Let's make it generate. So we are done with the third. Next primitive cylinder, instead of add metal make it slice metal. So this is 62.5, y component is 65, z component is equal to 0, and your 95.3. So this x component is 95.3. So let's make it sorry, so not 95, 75.1, 75.1. So let's make it generate. Create primitive cylinder, instead of add metal make it slice metal. X component is 62.5, the y component is 65, z component is equal to 0 here, and x component 95.3. So 95.3, let's put it on the other side, make it generate. So create primitive cylinder, instead of add metal make it slice metal. X component 115.5, so put it 115.5. Z component is 62.5, then y component is 65, this is equal to 0. So let's make it generate. So we have generated all 18 cells. Now it's time to generate the casing. So just ensure that each and every object has been differentiated with respect to the pack which we have considered. So here, this is the first part is done. Now it's time to prepare the casing. So create primitive, that is cylinder, instead of add metal again I will put it slice metal. Now the dimension will slightly change because the diameter is 19, so the casing radius will be equal to 9.5. So this radius now will change it to 9.5, remaining parameter will go on to same. So 65, let's make it this is equal to 0. So first component is 14.5 and 14.5. So put x is 14.5, z is also equal to 14.5. So let's make it generate. So the casing has been generated. So create let's say primitive cylinder, instead of add metal make it slice metal. X component now will be equal to 34.7. So put this is 34.7, z component is 14.5, this y component is 65, this is equal to 0. So let's make it generate. Okay, so create one more time primitive, that is cylinder, instead of add metal make it slice metal. X component, sorry, z component will be 14.5, y component will be 65, this will be equal to 0, and the third component we are having it is 54.9, so that is x. So let's make it generate at the third place. So you can see it is generated for the third. So create primitive, that is cylinder, instead of add metal make it slice metal. Z coordinate will be 14.5, this y coordinate will be 65, this is equal to 0, and now x component will be equal to 75.1. So put this is 75.1. So let's make it generate. So create, go to the primitive cylinder, instead of add metal make it slice metal. Z component will be again 14.5, this is 65, this will be equal to 0, and the last x component we required is 95.3. So put it 95.3 here, and let's make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. Z component will be equal to 14.5, this is y component is 65, this is equal to 0, and let's put the x component, that is 115.5. So 115.5, this is your component, and let's make it generate. So we have generated for the first row, similarly we have to generate it for the second one. So primitive, that is cylinder, instead of add metal make it slice metal. X component will be again 14.5, z component will be equal to now 38.5. So this is 38.5, so this is 65, let's make this component to be equal to 0 and generate. So create, go to the primitive, make it cylinder, instead of add metal make it slice metal. Z component will be equal to 38.5, so put it 38.5, this y component will be 65, this z component will be equal to 0, and the x component will be equal to 34.7. So put it 34.7. So we are for the second positions. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component, sorry, Z component is 38.5, Y component is 65. This is equal to 0. And now let's look for the X component, that is 54.9. So put it 54.9. So will be at the third position. Create, go to the primitive, cylinder. Instead of add metal, make it slice metal. Z component will be 38.5, Y component will be 65. This is equal to 0. So search for the X component, that is 75.1. So put it 75.1. So let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be now 95.3. Sorry, just check it. Yeah, 1195.3. So X component is 95.3. This is 38.5. Then this is 65. Let's make this equal to 0 and generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. Z component is 38.5. So this is 65. This is equal to 0, and the is 115.5. X component is 5.5. So let's make it and generate. So we are done it for second. So go to the primitive, one more time, cylinder. Instead of add metal, make it slice metal. So Z component, sorry, X component will be 14.5. This is 65. This is equal to, sorry, Z component is equal to 0, and your 62.5. So make it 62.5, and let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will, so 62.5 is the Z component. This is 65. This is equal to 0. So let's put the X component as 34.7. So put it 34.7, and let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. Z component is 62.5. Y component is 65. This is equal to 0. The third value is 54.9. So put it 54.9 as an X component. So let's go with the third part. One more time, go to the create, primitive, cylinder. Instead of add metal, make it slice metal. This is 62.5. This is your 65. This Z component will be equal to 0, and put the X component as 95.3. So sorry, 75.1. So 75.1 will be your the fourth component. So let's make it generate. Create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. 62.5. Y component is 65. Z component will be equal to 0, and let's put the X component 95.3. Here it is 95.3. Let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. Z component is 62.5. Y component is 65. This Z component will be equal to 0, and your X component is 115.5. So make it 115.5. So we are done for the last one. Let's make it generate. So we are done the geometry for the we are done the casing as well as the cells for the pack. So we'll first save the work and then we'll proceed. So click on the save button, go to this PC. Okay, so we'll prepare a separate folder, so with the name of thermal management of lithium-ion battery pack with rectangular channel sorry, pack with rectangular block and fluid flow through channel. So this is the name which we have put. So I will just copy this address. So we'll save with this name and click on. Okay, so we have saved the work. So one more time, just check it. And now it's time to prepare these pipes. So initially the pipe diameter will be 3, which is passing through the we can say aluminum block. So that is what we have to ensure. So create, let us say, primitive, a cylinder. Instead of add metal, make it slice metal. Now the orientation is here. I don't want this orientation. So the total length is 130. So I will put x component as 130. Z component I will make it 0 here. uh, Radius will be 1.5 here. So it is right now, it has been generated at this location. So you can see the position here. So this is 3, and okay, just a minute, I will just need this dimension. Okay, this is 1. Okay, so 1 plus 1.5, that is equal to 2.5. So I will shift this z coordinate by 2.5 here. I shifted to z coordinate by 2.5. Radius is 1.5, and let's make it generate. So you can see the object is generated here. Okay, so this is the pipe through which the fluid is going to flow. So this is actually the part of our aluminum block. We took the, sorry, we need z component also. So here we have to shift it upward. So let us say again, I take it 2.5, make it generate. Sorry. Okay, so this is the one of the arrangement which you have provided. We can have such n number of arrangements on this side. So these are the dimension we have to follow in the side view. So accordingly we'll make some changes. So actually I had prepared the geometry, so accordingly we'll make the changes for this. So first the last cylinder, that is at a distance of 62.5. So I will take it 62.5 here. So make it generate. Then this one, it is 52.5. So I did it slightly wrong by 1. This is 42.5. So let's make it generate. So the 40, so 32.5, let's make it generate. And now 39, so 22.5, so let's make it generate. And 30, this is 12.5, make it generate. Yeah, so last one, that is 37, it should be 2.5, and this is y component to be equal to 2.5. So now it is generated. So this is what we have generated as the channels through which the fluid is likely to flow. So now we have to generate it on this side, and this side. So accordingly we have to proceed one more time. So let's click on save the button. Okay, so now create one more time, say primitive, that is cylinder. Instead of add metal, make it slice metal. So x component here is 130, radius will be the same, this will be equal to 0. So now I need to shift it by y coordinate. The first one is 2.5. So here now the z coordinate will be as per the dimension, so 26.5. So this is 26.5, so it will be here. So let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. So this is x is 130, z component will be equal to 0. So instead of add metal, make it, okay, so I already slice metal. So the y component will be now 12.5. So this is 12.5. Z component is 26.5. So this is 26.5, that will be same throughout. So let's make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice. 26.5, so it was 12.5. This is x component is 130, z component will be equal to 0, so y component will be now 22.5. just check it. Yeah, 22.5. make it generate. So it is here. Create, go to the primitive, that is cylinder, instead of add metal make it slice metal. This x component will be equal to 130, this is equal to 0. Z component is 26.5, this will be common. Now this will be equal to 32.5. Now this is the next location. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. This x component will be equal to 130, y this is equal to 0. Z component is 26.5, the y component is now 42.5. So let's make it generate. So one more time, create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component is 130, this is equal to 0. Z component will be equal to 26.5, y component now will be equal to 42.5. 52.5, let's say, okay, 52.5. let's make it generate. So last one, create, go to the primitive, cylinder, instead of add metal make it slice metal. X component is 130, this is equal to 0. Z component is 26.5, the y component is equal to now 62.5. So we reach to the end location. So we are done with the second column. Now next, one more time, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component will be equal to 130, Z component will be equal to 0. Now let's check 50.5. So Z coordinate will be 50.5. So first y coordinate is 2.5. So make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. This x component is 130, z component is equal to 0. This is 50.5, so this is 50.5, this will be equal to 12.5, and let's make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component is 130, this is equal to 0. This z component is 50.5, just check it. Yeah, 50.5. Y component is 22.5. So make it generate. So create, go to the primitive, cylinder, instead of add metal make it slice metal. X component will be equal to 130, this is equal to 0. Z component is 50.5, y component is 32.5. If it is, yeah, make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component is 130, this is equal to 0. Z coordinate is 50.5, y coordinate will be equal to 42.5. let's make it generate. Create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component is 130, z component will be equal to 0. This is 50.5 and this is your 42.5. let's check. No, I think 52.5. Yeah, make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X is 130, so y, let's make this equal to 0. Z is 50.5 and this y component will be equal to 62.5. make it generate. So we are done it for the third column. Now similarly you have to go for the last one. Primitive, cylinder, instead of add metal make it slice metal. x component will be 130, z component will be equal to 0. Now let's check the dimension, that is 74.5. So z is 74.5, then y component is 2.5. Make it generate. So first one is done. Create primitive cylinder, instead of add metal make it slice metal. X component is 130, this is equal to 0. This z component is 74.5, so make it 74.5. This is 12.5 and make it generate. So one more time, create primitive cylinder, instead of add metal make it slice metal. Z is x component will be equal to 130, z component will be equal to 0. This is now will be equal to 74.5 as it is. Y component will be 22.5, so let's make it generate. So create, go to the primitive, that is cylinder, instead of add metal make it slice metal. X component is 130, z component is equal to 0. This z is 74.5, y component is 32.5. Create primitive cylinder, instead of add metal make it slice metal. X component is 130, z component is equal to 0. This is 74.5, y component is 42.5. Create, go to the primitive cylinder, instead of add metal make it slice metal. X is 130, this is equal to 0. Then z component is 74.5, y component is now 52.5. So let's make it generate. Create, go to the primitive cylinder, instead of add metal make it slice metal. X component is 130, z component will be equal to 0. Now this 74.5 and this y component now will be 62.5. So make it generate. So we have generated for all. Let's save the work before proceeding. Okay, the next process is now to make this also as a hollow. So there is one way you can actually select this cylinder and make it hollow, and then fill the fluid inside. So this is one of the option which is available, or you have to follow the same process what we have done here for this cylinders, and you make some internal region where the fluid has been present. So later on it also need to be defined as a fluid. So this is one additional option may be required to be done. But you can actually provide thin surface also here. So let us say in a thickness, if I want is say 0.5 mm, and if I generate it, you can see this is becoming hollow. Or if I just make it 0.25 thickness as a as a thickness, you can see the thickness is changing. Okay, so you can actually have this and this zone. So depending on whatever thickness you are having, so I may provide, let us say, 0.2 mm thickness, and this is what the region will be. So the simple process will be to specify the thickness here. So create 0.2 mm as a thickness, and let's make it generate. So in this way, one by one it will be generated for all. So this is the process we have to do. Let's save the work before proceeding. Okay, so let's continue with the work which we have specified. So specify thickness, that is equal to 0.2 mm. So make it generate. So one by one you have to do. So go for each and everything. So we have done it for 62. Now let's make it 61. So this is 0.2 mm as a thickness I am specifying. You can specify less also. So 60. So let's take 59, make it S. So 0.2, you can put it 0.1 mm also, depending on whichever thing you're having. This is just for your reference which we are putting 0.2 mm. So let's make it generate. So the first column has been done, 58. Let's go with 57. Yes, let us say 0.2 mm and make it generate. Then 56. So here 0.2, make it generate. 55. So let's say 0.2, make it generate. Then 54, let's say 0.2. So you could have done this process earlier also, but I am doing it later. So 54 is done. 53, make it yes. So 0.2 and make it generate. So I think we are okay. We are done with 53. So let's take 52 and here yes 0.2, make it generate. Similarly 51 we have to do here yes 0.2. Next 50 you have to do 0.2, make it generate. Then 49, make it yes 0.2, generate. 48, make it yes 0.2, make it generate. Then 47, make it yes 0.2, make it generate. Then 46, make it 0.2, let's make it generate. 45, make it 0.2, make it generate. So this is one by one we are doing. So then is 44 is required. So S, make it 0.2 and make it generate. So then 43, make it 0.2 and generate. So we are up to here. Then 42, so make it 0.2 and let's make it generate. So here then 41, specify this one 0.2, make it generate. Then 40, so S, make it 0.2, let's make it generate. 39, yes, make it S, put it 0.2 and make it generate. Then 38 we have, so make it 0.2, generate. Then last one I think 37 is there, so make it yes, this is 0.2 and this will be the last one. Okay, so we have done it for all. So the geometry is actually, most of the part of the geometry has been done, but still we have left with some kind of aluminum block structure which we can see in this view of an object. So that has to be generated. So one more thing which we required is the distance from this point to this location. So this will be required for us, and accordingly then we have to proceed further. So first of all, let's save the work and then we'll proceed. So the dimensions which are specified in the white, so we have required that. Accordingly, we have to actually do some modifications in the geometry. So that may be in the form of slice operation again. So what I will do here is I will create a plane. So I want to visualize this geometry one more time. So YZ is the base plane that I am going to take as a base plane. So I will select the YZ plane as a base plane because I need to slice the geometry along YZ. So I need to prepare that. So let's transform this, let us say offset. Now you need to just take a look at, this is the Z component, so put it offset Z. So as per the first case, the dimension will be 6.5. So make it 6.5 here, and let's generate and do the slice operation. So slice by that plane, make it generate. So now what you can see here is this one. This is the portion which has been cut. So this is what we required. So one more time I will just create a new plane. So here base plane, you can take it the YZ. So YZ is the base plane I will take. Then I will make it offset Z, offset Z. So as per the dimension, that is 22.5. So I will put it 22.5 here and make it generate and do the slice operation. So this is how the object is getting sliced. So one more time, new plane. You can actually, if you know the distance between these two, that is this and this, you can actually create it 4.2 here, and accordingly also you can do, but I will specifically take it the base plane as the YZ. So make it apply, make it offset Z. So check the dimension, third dimension, that is 26.7. So put it 26.7. So it will be here, generate, then do the slice operation, make it apply, and then generate. So one more time, create a plane. So from YZ plane I take, make it apply, make it offset Z. So just check the distance. So 42.7. So make it 42.7 here. So and generate and do the slice operation. So you might require some more rework over here, but this is the best process to go for. So plane, we have to take it to YZ, make it apply, make it offset Z. So 62 46.9 I will put, sorry, just check, yeah, 46.9 I will put. So 46.9. So the plane will be here, generate, do the slice operation, make it apply, and then generate. So one more time, create plane, from YZ plane, make it offset Z. So the dimension now will be equal to 62.9. So put it 62.9 and make it generate and then do the slice operation. So one more new plane, now YZ plane you have to take, make it offset Z. So the dimension which we are going to do, 67.1. So put it 67.1. Let's make it generate and do the slice operation. So one more time, create the plane, base plane will be YZ, make it apply, then offset Z. So here 62 7.1 83.1. So put it 83.1. So make it generate and do the slice operation, make it generate. So one more time, create the plane. So base plane will be YZ, make it apply, make it offset Z. So now 87.3, I will put 87.3 here, make it generate, do the slice operation, make it apply, and then generate. So next, one more time, select YZ as a base plane, make it apply, make it offset Z. So now 100 103.3 103.3. So take it, generate, do the slice operation, make it apply, and then generate. So one more time, select YZ as a base plane, make it apply, then offset Z, then 107.5. So 107.5, make it generate, do the slice operation, make it apply, and then generate. So next is YZ plane, make it apply, click on offset Z, then next distance is 107 point, sorry, 123.5. Just take it 123.5. Okay, 123.5, make it slice, make it generate. So in this way we have separated out each and everything. Now we need to remove some of the unnecessary parts which are not required for the geometry, as well as we have to do some Boolean operation. So this is again we are done as of now creating the planes and some of the aluminum blocks we have to prepare. So accordingly, so this is one of the operations has been done. So some further process is required. We'll just save the work and then we'll continue. Okay, so what is the next process? Next process is to make the object has been sliced, so because of which some geometry changes has took place. So we have to make this body again unite. So for this some of the basic operation I will require, so I will do that. So the cylinder has also become slice. I don't want the cylinder to be a slice one. So why we are done is slice to make the aluminum block, so that's why we are done. So one more time we'll slightly do some rework on the geometry and make the geometry to be unite. So this three part will make it unite, and then accordingly we'll proceed further. So this might involve some rework as I said, but this is the proper way to proceed for applying the boundary conditions as well as specifying the aluminum block. Okay, so for the cell is, as far as the cell is concerned, we are done it. So go to the create boolean, make it apply, and then generate. So we have generated the cylinders has been made as a single uniform body as of now. So now similarly we have to do it for the casing. So slightly zoom in and accordingly we'll proceed. So only select the part of the casing and carefully select only the part of the casing. So this has to be done carefully, otherwise the geometry again may require rework. So you have to select it carefully. Okay, ensure that everything is selected. Now go to the one more time boolean and make it unite and generate. So now you will see the casing and cylinders are being separated out with respect to each other. Now it's time to do the things which are related to the cylinders. So this is the aluminum block which we are having. So I can actually hide the bodies which are related to aluminum block, and accordingly we can proceed for. So these are your aluminum blocks. So they are throughout. So I will select the aluminum blocks, and so these are the aluminum block I am selecting at the top. Or first let us say select cells, make it form new part. So make it form new parts. So you can differentiate this here itself. So I will select cell, then select the casing, Okay, so form new part for your casing. So specify the name also. Here I will put it casing. So this is important in order to proceed for the remaining step. Here I will put it aluminum block. Ensure that all of them are selected. Save form new part. So I will put it here. So aluminum block I have put. Now the major task is we have to do the Boolean operation for. So I will hide this body, and then I will hide the aluminum block also. I will hide the casing also. I will hide the cell also. Okay, so this is what we have done. So these are the geometries which are in between. So this is also I will hide. The purpose of doing this is to make the fluid and solid zone, to visualize the fluid and solid zone. So first of all, depends like how you are proceeding. I will select all the outer surfaces first. See here, and make this as a Boolean operation. Don't select the internal faces because internal faces are different. So carefully do this. Okay, so we'll do one by one, otherwise. It might be slightly lengthier process, but better way to go with this, because we want to avoid any we can say internal surfaces where getting selected. So 1 2 3 4, and this is 5 and 6. So just check it here. So this is for the this outer layer has been done for here. Similarly we'll do it for the other one. You need to ensure each and every faces are selected, otherwise you might end up with some errors. Okay, this is what is completely done. Now I'll select all this. So create boolean, make it apply and generate. So you can see this is the single object, this is also single object, this is also single object, here is also single object. Now this single objects I can now hide here, and whatever are left they are all okay. So this is one. Okay, so we have to do slightly rework again because these two are missing. Okay, so undo the boolean operation. Okay, this is for this. We'll just check it, this one first. So show all bodies I do again. Okay, so one by one again I will hide some of the bodies. So this is the aluminum block that we are going to hide. Then casing also I'm going to hide. The cell also I'm going to hide. Okay, so this is the only part which is left. So this is also we are going to hide. So hide this body. Yeah. So now one by one we'll do it again. So this is done correctly, I guess. Just check it. Hide body. No, this part is missing here. So we have hide the all bodies. So what I will do, I will just select this faces and will make this objects to be unite. We have to ensure that we are selecting it proper. No one should be miss. So this is what we have to ensure. Selecting. So create boolean. So now just check the all internal parts. So we have yeah, we have remove we hide the body now. Now these are all internal parts left. If let's check if anything is missing. So if it is not missing, you can now do the one simple operation which is called as select all and then make it unite again. So click boolean and then generate. So now this is your the fluid zone. If I select this here, I will rename this, let us say form new part. So I will mention this as a fluid zone. So let's say this is, or specify the fluid zone. Now this is your fluid zone, this is aluminum blocks. So one more time I will show all bodies. So fluid zone, it is here, aluminum block is here, casing and cell. So one by one I will hide the bodies. So cell is again hide, this is also hide, aluminum block is also hide, the fluid zone is also hide. So what we left now is the pipes and some extra things. So let's hide this also. So what is left out now is only the pipes. So let's say select all here and make it form new part. So I will define this as channel, or if you see it is aluminum channel, I will specify. Or maybe like a copper or something. So this is here cell, casing, aluminum, fluid zone and aluminum channel. So now make it show all bodies. So here we have this bodies. Some of the parts are unnecessary for us. This one, this one, this one, this one, this one and this one, this one. So these are unnecessary part for us. So I can just click on delete, make it apply and then generate. So you can see now the geometry has been prepared like this. So here, so one by one now we will define this. This is your cells, this is your casing, this is your aluminum blocks, this is your fluid zone which is inside, and this is your aluminum channel. So the fluid zone is outside, the channel is out. So now we have to do the naming for each and every case. So let's say this is a cell. So we have to define each and everything with the same name, that is cell. So you have to do that operation again. So click on this cell. So whatever the numbers we are having, so you have to do it every time so as to avoid the repeated boundary condition that need to be applied in the setup part. So you can actually define cell 1, 2, cell 2, cell 3 and so on, but this will adds up the number of boundary condition that will be available in the setup part. So preferably try to specify with the same name, that is, let us say a common name like cell. Don't try to put it 1 2 3. You can put it 1 2 3, but you have to apply separately the boundary conditions for each and every location. So I just specified cell here for each location, make it cell. So this is cell. So try to give the same name in that part. So cell is done. Now let's move towards the casing. So this is the casing name we will give it for all. So here put it this one, casing. Casing. Okay, so the casing name has been done. Now same way we have to do it for aluminum block. So these are the blocks we are having. So accordingly I will specify the names. So aluminum block, whichever is been available, you have to put it there. So the block name has been done. Same way you have to define the fluid zone. So make it copy. So wherever you are observing fluid zone, you have to specify that. So instead of the aluminum channel, I will put it as a copper channel here. So say make it copy. So do it for all. You can put the material as per the requirement. So this is just for a reference. So all the naming has been done. So whichever is the fluid zone, that you have to specify as a fluid only. So this is the fluid zone, so make it mention as a fluid. So that is one important thing. And the rest of the thing, cell is your solid. So aluminum is all, casing is also solid. This aluminum block is again as a solid. So you don't need to actually make this as separate. So all this will be solid. So this copper channel is solid. So let's save the work and then proceed further. So as far as the geometry part is concerned, the things are over. So you can just check it once, check it. This is the outer region and this is the internal region. These are the aluminum block. You can actually make this casing and aluminum block maybe of the same metal, so that is also can be done. So this may advantages in terms of reducing the number of boundary conditions which are being required. So this is one additional thing which can be done, but I preferably kept it a different one. Cell, this is your casing, aluminum block, fluid zone and your copper channel. So casing we are ultimately will going to make it as a aluminum only. So if you want, you can keep it as it is or you can proceed with the other part. So now the geometry preparation has been done. Now we'll move to the next part that is related to your mesh. So let's click on mesh, click on, so we have generated the geometry. Now let's proceed for the mesh. So click on edit. Okay, so the such kind of errors are observing nowadays because of the updates. So I just click on clear generated data and we'll close the meshing file, and once again I will open the meshing file once this file is closed. So just click on edit. Now you will see the mesh window will be visible. So this is now the object is visible. So let's say fit to window. So I will select the mesh size that 0.001. So that is the element size we will take. So click on OK and let's generate the mesh. So we can take it 0.005 also, sorry, 0.0015 also, but it will be take a very small element size and there are chances that the system may not respond. So that's why we took 0.001. With this also we'll definitely will get quite better mesh. We'll just look at the statistics over here of the current mesh once this is been completed. You can actually click the parametric option also, so that we can generate the different sizes of mesh and accordingly we can visualize it. So preferably here we'll go with the current element size, which is when we are set at 0.001. With this element size, whatever the time required, so that we are going to visualize. So 73% has been completed. Okay, so this looks to be quite better mesh. So accordingly now we'll provide the name selection on its domain. So select the respective region and accordingly we'll define the name selections here. This may not be a very good mesh, but considering the capabilities of computer, we'll consider this mesh for our study. So specify all these are inlet. Okay, so create name selection, specify all these are inlet. Similarly, specify all the others on this other side outlet. So create here. So create name selection, I will specify these are all outlet. So inlet outlet has been specified as you can see here. So now I will go to the geometry, and in the geometry I will select cell and hide all other bodies. So when I do cell and hide all other bodies, I can able to select all the faces. So I will select all these faces, and this will be useful for me in order to know the cell temperatures. So that's why I will put here as a cell boundary. So later on they will be visible as cell boundary contact regions. So once this is done, I will just click on update. So you will see a mesh translation to fluent successful kind of message. So once that message appears, you can actually proceed for the next part that is related to the setup. So here I will make it show all bodies, and one more time you may just click on update. So apart from that, if you want to specify any convection at some other places, so you may specify that particular surface for convection. So now this part is over, so I will just close with the meshing part. Now I will go to the setup part that is related to your. Okay, so wait till this is loaded. So once the mesh window is done, I will proceed with the setup part. So let's click on edit. Okay, so I will just make it reset. So if anything, okay, so click on edit. So provide the number of processes. I will put it to 16. You can put it as per the number of numbers your computer can have. So I am putting it around 16 for my case. So once the geometry is loaded, you can actually proceed for the next step. So the geometry loaded should be visible with some kind of arrows like inlet and outlet, as we are specified during the mesh. We have done the name selection at inlet and outlet. The same should be appearing on here. So because of the higher number of nodes and element, the system may take some time to load. So once the object is visible, you can set the transient and gravity. So you have to select the respective direction for the gravity also once the object is loaded. Okay, so you can see the arrows which are visible. So select transient. So still it is not loaded, so we'll wait. Okay, specify transient, then specify the gravity option. So gravity will be minus 9.81. Why minus 9.81? This is positive direction, so negative will be your gravity. So energy equation I will turn it on. We are not having any multi-phase model, so I am not going to turn it on the multi-phase. So I will select K epsilon, enhance wall treatment, thermal effect and curvature correction. So let's make it okay. So we are not having any kind of PCM metal, so I am not selecting any solidification melting. So first of all, I will select the fluid. So the fluid from the database I will select, that is a water liquid. So click on water liquid, which will be flowing through the channels. So make it close. Now next is, first of all I will specify the lithium batteries. So I will say lithium cells. Here also I will select lithium cell. So make it change create and make it, sorry, we need to put the values, just a minute. Okay, so I will put the value, that is 2775, and then 880, and the thermal conductivity we are saying is 3. So this is the value which we are considering for lithium cell. So make it change create and then click on close. So next material want to add is the solid material. So click on solid material. I will select the aluminum because we have the aluminum blocks, so we have to add this. One more material that we are going to add is your copper. So select the copper and make it copy and then close. So now next step is to go to the cell zone condition. So make it zone type. So fluid zone, we have to specify which fluid is there. So as you remember, we have selected water liquid, so you have to select the option of water liquid here, then close it. Then aluminum block is there, so aluminum block, the material should specify aluminum, so make it apply and then close. Next is your casing. The casing should also be of aluminum, so I will select the aluminum material. Okay, the next is your cell. So the cell is made up of lithium ion, so I will select the source term, click it 1. I will select constant. So you have to select the heat generation per unit volume. So I will select the heat generation value. Just a minute. So I will select the heat generation value as 104017. So make it okay, make it apply, and then close. So copper channel, again you have to select the respective material. So it is your copper. Make it apply and then close. So we have defined this. Now we need to specify the boundary condition at inlet. So inlet velocity I will specify, let us say 0.2 meter per second. So let's make it apply here and then close. Now let's come at the bottom. So wall copper, you have to select the respective material. So select copper here, then wall cell, you have to select the respective material, that is lithium cell. So that is correct. Then wall casing, you have to select the respective material. So casing will be made up of aluminum, so you should select the material, that is aluminum, make it apply, then close. Wall aluminum block, here also you need to select the respective material, that is wall aluminum. So here make it apply and then close. If you want at some point you can to put some convection, you can specify the value of convection also. So cell boundary contact region, so this should be made up of aluminum as a cell boundary, sorry, made up of lithium. So that's why you have to, by default it is lithium option is available, so you don't need to we can say change it. But if it is not there, you have to change it. So just confirm it once. If by default it has been taken lithium cell, so you don't need to worry about this, but you also need to check these options. Okay, so next is your report definition. So go to the report definition. So new, I will take area weighted average. So here I will select temperature, then I will select the total temperature. Now here print to console, I will select here as a total temperature system report definition. So select all and click on OK. So this is the first one. Similarly, surface report area weighted average. Here I will select temperature and here I will select again the total temperature. Now here I will select only cell boundary contact regions because I want just temperature of cell, so that's why I am selecting only cell boundary contact regions. So this is the task we have done in the mesh because we are, if you remember, we have specified the cell boundary contact region, so that is helping us here in order to identify the parts. So here I will put as cell temperature curve, so make it okay. So we have specified two things, total temperature curve and second is the cell temperature. uh, Now next is you have to go with the initialization. So once initialization is done, you can actually proceed for the iteration process. So let's wait. So depending on the capabilities of your computer, the time required will be more or less. So click on calculation activities. So let us say I put it 20. Then go to the solution animation, new object, contours. So I will select temperature. Here I will select total temperature. Now I will select all. I will go to the color map option in order to have a scale which is not exponential. So make it float option and click on save display. Once you click on save display, the object will be visible in on this particular window. So once that is done, you can actually proceed for the next part. So depending on the capabilities, again the time required will be more or less. So you have to wait till it has been loaded. Okay, so it has been loaded now. So make it slow display and then let's close this window. Total temperature contours 1. So I will select total system temperature animation 1. So make it okay. Now similarly one more animation I will set, that is total temperature of cell. So here total temperature, I will select all cell boundary contact regions. And lastly you have to select the wall cell. So go to the color map option. If you don't want the exponential scale, select the float one. make it apply, and then click on this. So now close this window, contour to, I will put here cell temperature animation. So I will may put here as, let us say, 2. So click on OK. Now you can go to the run calculation and just put some value here, number of time steps. So initially I will put it 10, and now I will run the iterations. So you have to wait whatever the curves which we have specified, like total temperature of system curve, cell temperature curve, and then we have specified the animation. So this will be visible once you are done with the first 20 iterations on this window. You will be in position to visualize all such 4 windows. One is total temperature of system animation, second is total temperature of cell animation, third one is your total temperature of system curve, and cell temperature curve. So just wait till the calculation starts, and accordingly we will visualize. So the window will be visible in just a while. Now you can see one by one all the windows are getting visible. So this is how the things will be visible once you are running the simulation. So the first one, what we say is the cell temperature. This is the scale residual which we can see. Then the total temperature of system, the curve which is we have set already. Then cell temperature curve. So this is also one of the things which we have specified. Then contours of total temperature, that is for your cell. One more thing I like to tell, we are not specified any kind of convection, but if some value is there at some places where you can actually put the value, as well as you have to specify this in the boundary conditions. Next one is the contours of total temperature, that is system. So this will show you the total system temperature overall. So this is how the simulation is actually going. We have to run this further, maybe for some long time, in order to visualize the results in quite better way. So this is how the curves that are actually been obtained. We will run this further, maybe for around 200 600, around 200 to around 600 seconds, in order to visualize how the system temperature goes over the period of time. So this is all how the animations that can be set and how the simulations that can be run. So depending on the capabilities, like I have tried with 0.001 as a mesh size, but if you have the better capabilities at your end, you can run it for 0.0005 also, or even you can, if you don't have that much of capabilities, you can with your computer system, you can go with 0.005 also. But definitely the accuracy of the results may be more or less depending on the element size which we are selecting. So this is one of the element size we have selected, not necessarily this has to be gone, but it depends on the capabilities of your computer also. So that's it. We'll wait once the results have been out, maybe for after 100 times steps we'll visualize, and accordingly we'll see the results after 100 times steps. So you can see the calculation is completed for the first 10 time step which we are run. So you can definitely see some variations in the color contours. This is for cell temperature. This is the curve which is obtained, which is the cell temperature curve. Definitely the cell temperature will be quite more than the total temperature of system, because the heat source is actually your cells. So accordingly, this is how the system is been run for some iterations. So we'll definitely will run it further in order to visualize the results in quite. So this is the outcome after performing around 100 time steps. So what we have observed is the cell temperature and the total temperature of system. Now this curve is getting flat after some time. So here also in total temperature of cell, so this is also curve becoming flat. So this is how when the flow rate of which we have selected, that is in boundary condition, I will show you. At flow rate, the one which we have selected was zero point 0.2 meter per second, and the source term which we have selected was 104017. So what I will do, I will now change the different value of heat generation rate, and accordingly we will visualize this. So this is how the graph also you can save it for the given we can say heat generation rate. So I will now just change the heat generation value. So let's go to the cell zone condition. Here I will put cell, and here I will put some different value now. Now I will put some value which is, let us say, somewhat higher, 282189. So let's click on OK. Let's click on apply. Now whatever the graph which has been generated, so this was for earlier case. Now I am running it for some higher value of heat generation rate, and let's see what changes will occur at this particular heat generation rate. So just one more time, just see how the curve is, how the temperatures are there. So now I will go on to initialize it one more time, because we have changed the value of heat generation rate. So you have to click on initialize. Once yeah, it asks you animation history, so click on OK. So one more time I will just click it over here, and now the system will again start from the same. So once this is completed, you can just click on run calculation, and let's see the process again. So first I will put it maybe around 100, and let's visualize what will happen at the end of 100 times. So we have to wait. So the maximum temperature which shows around 310 when we are use the heat generation rate as 104017. Now we are taking a higher value, that is 282189. And what will happen at this heat generation rate, that we will visualize with the help of the next simulation. So once first 20 iterations are completed, you will see this graph will again start from 0. The total temperature of system, this also again start from 0. So likewise, you can run the simulation maybe for different heat generation rate, as well as if you want, you can go with the different mesh sizes also. So likewise, the simulation can be visualized at a different heat generation as well as different mesh values. So as per the new heat generation value, we have performed the iterations. So the total temperature of contours of total temperature of cell. So this shows you the total temperature of the system curve, which is becoming flat. Then total temperature of cell curve. So this is the second curve, and this is the contours of total temperature, and this shows you the contours of total temperature for the whole system. So we are running it around 300 flow time. So if you change the value of heat generation per unit volume, accordingly you may get some different value. So the figure shows the scale residual, number of iterations that has been performed. So this curve shows the cell temperature with respect to the flow time. So the curve becoming flat over the period of time. So as we can see the trend, it becomes flat. So what we can assume is the cell temperature doesn't go beyond that particular limit for the given value of heat generation, as well as whatever the flow velocity we have taken for the fluid. Next, this is the total temperature of system. So system temperature will be slightly lower than the cell temperature because the cell are likely to get heated more as compared to the total temperature of system. Next, this is the contours of total temperature for your cell. So that shows the variations in the temperature with respect to the again time. Next is the total temperature of the whole system. So most of the heat is being concentrated at the latter stages. So you might see if you run this simulation further, you might see some further more changes over there. This shows the animation of cell temperature with respect to the flow time. How the cell temperature is varying with respect to flow time is visible with the help of this animation. The animation video shows the particles while moving from inlet to outlet. You can see the color changes in the particle, so that can be visualized as heat has been taken by the fluid particle from the aluminum blocks.